All right, so welcome back. This is we're going to continue down the line with pandas. We've already covered some basics of what pandas is and what it can do. And now and we looked at the series, which is the one-dimensional array-like object, just like we had with numpy.array. Now we're going to look at the what's called a data frame, and these are we had the one-dimensional array in NumPy, and this is a set of collection of columns. So think of it, oftentimes, I think the easiest thing to visualize a pandas data frame is like an Excel spreadsheet, but it's all in memory and it can do a lot more stuff. And we're going to manipulate it through code instead of clicking on a bunch of buttons within a GUI. So we're going to first look at creating a data frame from NumPy. And we explained before that Pandas relies heavily upon NumPy to do a lot of things. So that means it can ingest a NumPy array directly. So here we're going to create a random array with the shape 2, comma 3. And we're going to have our 3 columns and 2 rows. And the index we're going to set as the word for the first row A and the second one B. And we can go ahead and we can get this information back, and we can see we have our index, which is A, B, and then the columns, which should be first, second, and third. And they come back as this type of index column thing. So if any of these arguments are left out, um, the data frame will put them in there. So notice we didn't put the column names in, and it just assigns each column a numerical value starting at 0 and going to n. And we can get an exact list, and you can see that they're just a range of indexes for each column. But that's not really helpful. So a lot of times you just want to use an exact name, a word name, something like first, second, and third, or to actually describe our column names. We can create data. We saw before also with series. So let's create some series values. So we have our first column values is going to be 1, 2, 3, and the second one we're going to give it a name B, and then we're going to have the values 4, 5, 6. So we're going to pass in first our first series of 1, 2, 3, and we're going to say here's the column name A. So let's see what we have. So now we have a data frame with the column S1 with those values 1, 2, 3, and the column name A. Or because we have a name, excuse me, or because we have a name right here, I forgot to run the cell, in our series, you'll see that it'll grab that name from the actual series and put it in. Another way that we can get information is that we can pass in information as a dictionary. So here we have our series 1 and our S1 and S2, and then we provide our column names as a key value pair. So here we get the same dictionary back with both columns A and B as expected. There's a lot of other ways we can create data frames, and we're just going to go through a bunch of different ways. Think of all the cursor examples that we had before and how we were taking the rows and transforming them into dictionaries. So we had these key value sets. Well, you can take a list of those key value sets and convert it into a pandas data frame. So here we have a list of dictionaries, 2 rows with various columns. So we have wage, name, and age, and we're going to go ahead and we're going to get back this information. You know, we could also add, this is also something that's pretty interesting. So let's say I have a column that only exists in one dictionary. What it'll do is it'll say, so I added height just there. And so dictionary A has a column that is in dictionary B, and see that it fills it in just with a null value, so that makes it pretty powerful. So you don't have to have all the information in. Here's another way that we can pass in information. So this is taking a list of lists. So we have one list and each row is represented as another set of lists. And then we explicitly define the column names. And we're going to get the same thing we had before minus the height. So I can change that back just so you can see that it's the same thing. Another way we can do this is, so we had each individual dictionary as a row. What we can do is for each column with a dictionary, you can pass in a list of values. So here's wage, and here's the 2 values that go in there. Name, Jack John, age, and this creates the same exact thing we had before. So these are just one of the multiple ways we can go ahead and create information. So it's very robust and it's very dynamic in the way that we can create information for either from nothing or from other sources and then feed it into our Pandas data frame so we can consume it. So um, we have now that we know how to create our basically our two-dimensional arrays, um, there are a couple ways that we can go through and we can start accessing this information. So we can access our column data and we can access our row data. And the way we can do that is by using, uh, there's this bracket notation. And we saw this with series. We would just put in a location, we get back a value, we get back our information. But you really have to be aware of what you're working for. So let's take a look at our data frame that we created before, and we can go ahead and recall what that is. This is just this wage name and age one, and we could try to get our information. So we could let's just say df of 0 and let's see if it brings it back. And what we're going to see is we get a key error. So this isn't a that's not a way we can get it. But we can go ahead and we can look and we can start accessing wage information and other information to get actual rows. So let's say we want to get the wage information. We can pass it in within the brackets, just the name, or it also accepts what's called dot notation, so df dot, and then the column name. Now there's a limitation with dot notation that if our column name has a space in between, you're going to have to use the bracket notation because it won't recognize if you have like a wage space amount. This wouldn't work because it would think that it was df dot wage and then you put a space in there, and then this was a amount would be a separate variable. So you would have to put it as the string on in cell number 20 above. We can also do use fancy indexing, so we can pass more than one column in. So here's getting two columns. So we're getting two sets of column data. So for the two for name and wage. We can also do some slicing on here, just like we do with lists. So we have df and then from 0 to 1. Let's see what we get. We get our 0. So we get our first row. We can also pass in queries on here. And this is what starts to make pandas really powerful, just like we saw in NumPy, either using the NumPy where or just doing a Boolean mask. This creates that same true-false Boolean array going up and down, and it'll only show the truth values. So we want to find the person who's making over 1200, and we can see we get back our one row. We can also get individual values by passing in a column name and then giving it an index. So notice we had to do df column and then our index. But let's see if there's a better way of doing this as we're going to go through. So we're going to go and we're going to do some alternate ways of accessing information. And this has to do with the lock and ilock. And you can use this dot lock and this dot ilock, and they're going to allow us to get the attributes on there. So and there's a bunch of different ways we can do this and use it. So it's multifunctional, so you can use it very basic and or the other one. But the real difference is that between lock and ilock is that attribute. It's basically you have explicit and implicit integer indices. So let's go take a look at what that actually means. So with lock, what we're going to do is we're going to say I want the first position on wage. And we're going to get back the value. And then we can say with ilock, I want the -1 and I want the -1 column. So it's going to give us our age going back. Now let's just remind everybody what our data frame is to help you out with some of these examples. And then what we're also saying here is we're going to do lock 1, and then we're going to pass in the two columns that we want along with that. And we can see that we get back our information here for our row, and we have name John, wage 1500, so as expected. So with ilock, everything works like NumPy did, with our indexing and our slicing and the masking and all these combinations. But with lock, it's the same, but the names in our explicit indices used for specifying the rows and columns. So let's see. So let's go. So that means basically you need to make sure that you know which type of index you're working with for the data frame. And we'll go on and we'll sort of retackle this a little bit later. But we're going to move on now to summary statistics. So we're going to load some information. This is that weather information that we've been working with all together. And we're going to go ahead and we're going to drop some information and we're going to take the average of three different the means of the columns, 3 different means. So we're going to look at the participation amount, snow depth, and error. So this gave us some general statistics that we can get about our data set. But let's say we want to just like we don't know exactly what we want to grab, but we just want to see the general statistics for any numerical column. We can do what's called the describe method, and it'll give us all this information for all the numerical columns in our data set. So here, you can see if we get all this information, the participation amount, snow depth, and air temperature, and this allows us to get some pretty important information or basic statistics for each one, which includes the count, mean, standard deviation, min, max, and then the data broken up in the 25th, 50th, and 75th quartile of our data set. So, but what you'll notice is that um, this data set we work with is kind of odd, is that it has a lot of information that's depicted as -1. So and for this data set explicitly, -1 means that that day had absolutely no snow or rain. So it'd probably be more apt in this case to set it to 0. And secondly, there's also columns that we're missing information. So we only have, if we look at the count for the snow, we'll find the count. Notice everything's 365 except for snow depth. So we're missing some information in that column. So how do we handle that information within that series? So we can go ahead and we can start looking at it. The first thing we're going to do is we're going to look at that snow depth field, and we're going to see what the unique values are in there. And we can see that we have a lot of values, but we also have this value called NaN, which means not a number, or you can consider it as null or none if you wanted to equate it back to a standard type within Python. And what we can do, so we're just gonna we can go ahead and we can replace it. But here's an example of how none works. So here we have just a series 1, 2, 3, and then we're going to add NaN into the 4th spot. And then we can also pass in none for this, not for objects that aren't numeric. You can pass in none as well, and it sort of works the same. And we can use this function to find all this information. So we could do is null at the end of the series, and it'll bring back a Boolean series that are false, false, and true. So we know that our second spot, which was none, is null. And the same thing with the not a number. So we're going to do this information on the whole data frame as a whole. So our weather data, we're going to say, hey, which data is actually null? We're going to go ahead and look at it. And we can, it's not very useful when we look at it this way. So what we can do is we can find columns on here on the axis. We're going to look at each one and just return back those values. So for the any. And we could also do the converse of this to also find everything that isn't null. And now we can go ahead and we can do things on this. So we could go ahead and we could drop all the NA values and also drop all these null values across the whole data frame. And we can see that it dropped out rows all across the information, and we're now, instead of having 365 days, we have 358 days. And it's probably, if it's just one column where we have our missing data, we probably don't want to drop it. So we can go ahead and drop basically columns containing missing data. So we can say, hey, drop any columns that have this NA data. And we can see that now we have 365 days still within our data set, but we lost that snow depth for the entire year. So that's probably not really good either. So there's a couple ways we can handle this. We can use these threshold parameters to determine the number of nulls that'll say, hey, this column isn't any good, or rows. But what we're going to do is we're going to take advantage of a function called fill NA. And there's a couple ways that we can do this. So there's 3 methods we're going to focus on, and we're going to focus on none, ffill, and bfill. None means that you're going to say, okay, DataFrame, for any null value, I'm going to replace it with this value. And you have to specify the exact value that you want to do it. We can also do fill NA with what's called ffill, which takes the previous value, uh, the previous not null value, and puts it into the first occurrence of that row. So that's one way to do it. So if our data was sorted, we could say that it makes logical sense for our snow depth that if yesterday it snowed, you know, uh, 1 centimeter, the day after it snowed 1 centimeter. So that's basically what we're saying. And then backfill uses the next value after it. So whatever that value is, and then it moves it back to that one previous row. And those are the various ways. So in this case, what we're going to do on our column that is null, we're going to uh, do a forward fill on our data, and we get back a new output. Okay. The next topic we're going to cover is converting data. And there's a lot of different ways we can convert data. There's built-in functions to go to and from different values. Like to convert to numeric data, there's a to numeric. If you have datetime, there's a to datetime, and you would use that a lot of times if you have timestamps, especially if you're pulling information from ArcGIS Online. The date time represented in a hosted feature layer or a feature layer comes back as milliseconds, and it's in UTC time zone. So here's one way that we can convert data. So I have a series, and it has the string 1 and 2. And what the map does is it's gonna call the function int, and it's gonna cast integer to the numeric value of 1. So let's see that. So now you can see we instead of having a series that's type object, which is a string, we have a series that's type int64. And we can cast that back. We can take numerical values and cast it back to string. We can also convert these values here. This would be a float-based one because we have one float value in there, and we're going to downcast it back to an integer using the to numeric one, and see that it converts it instead of an int64, it's int8. And there's some advantages to having int8s over int64 if you have very, very large data sets. These have a smaller footprint into in memory. So we can also do to numeric, and we can set the errors to coerce. It's going to put NaNs in for the value. So here it said, okay, I can't change A into a numerical value, so I put not a number in there for that value. The preferred way, and I recommend, is that when you have a data set and you want to change it, you just do series.asType, and then you put your type in here, and this will convert our numeric values into string values. To know what your data set's in, you would do df.dtypes, and that stands for data types. So here we have our data frame with our column names A, B, and C, and our integer values. So you see we put out our D types. We have D types are all int64 for A, B, and C, and then here's our data. Now we can cast this information to floats, and we can see that it does the cast for us. Or we can say as data type, and we can only convert specific ones. So if you had a whole bunch of data that you were bringing in, or that was in your data frame, and you only need to, instead of having to chain as types over and over again, you could just do do as types and pass in a dictionary, and so we can cast or convert B to float and C to string, and we can see that it produces the data frame in the way we want it, where B is now floats and C is our integer. So far we've worked mainly with string data, but let's take a quick look at numeric data, but let's take a look at how we can work with string data. So we can use that map function that we had before, but there's actually a string workspace within Pandas that's created just to work with string data, just like we do with Pandas, the Python standard type, we can do string processing off the str namespace. So for you would do, in this case, we have a series. So we do, and then we do series.str, and then we can call those string functions that we have on a regular string object if we're working on it in Python. So here we can capitalize the first name of our all lowercase letters, and we get Donald, Teresa, Angela, and Vladimir. Or we can go ahead and we can put them all to uppercase. So here's another example. Or we could do something interesting. This will just put it back into the original. So what we did is we actually went names.string. We changed it all to capital, and then we changed it all to lowercase. So you can chain these methods together as well. But here's the original. And then we can also do operations like split. So if you have your names and you want to split it by the space, we could just take our full names and then split, and notice that we have an array of a series of lists. And then that's probably not exactly what you wanted when you do the split. So when you do your split, you just set expand to true, and that should split our column into two new columns as a data frame. And notice that we get it just assigns it that 0 and 1, and then it creates the names in two separate series. And then you would go ahead and update those columns as needed. So those are just some powerful things we can do. But let's go ahead and just quickly jump right into another notebook. And I'm just going to do an import, and we're going to look at some things that we can do. First thing we're going to do is we're going to look at concatenating data sets. So I'm just going to go ahead and I'm going to create a function called makeDF, which is just the helper function, and create some data. So I'm going to make some data frames just for our example purpose. So I'm going to create a couple. Now I'm going to concatenate two data sets, and I'm going to do a real simple concatenation here. So I'm just going to take my first data set and I'm going to smush it together with my second data set, so A with B. And this is just going to produce, notice we get an index, it doesn't maintain the index, and our new data A0, B0, A1. B1 is smushed together with A2, B2, A3, B3. Now, we can also go ahead and we can concatenate the same two data sets together as well. But notice something different is that our concatenation caused a repeat in our index. So if we go and we do the lock location to find it, notice that we get back our two values. And this is probably not what you want. So there's a solution to this. So first we want to deny, we want to basically say don't create the double index. What we want to do is you want to verify the integrity of this. So let's go and see what happens. And by putting that in, it says, hey, you're going to have overlapping values. So the way to get around that is to say, I want to ignore the index and create a new one once the data's been merged together. So here you see that the index was like the first time we did the concatenation in 0, 1, 2, 3. So it drops that index, creates a new one once the two data sets are smashed together. We can also do some hierarchical indexing. So this is going to make us have more than one dimensional index. So here we could say, hey, for each concatenation that we're putting together, I want an index that says this is part of first and the other one's part of second. So with our first A, it's going to give it first and it's going to be 0 and 1, and then second and A1. And it's kind of like when you join data on a field, you can give it a left and right. You give it a left and right suffix to say where it came from if there's duplicate data. So we can go ahead and access our data by saying I want column A in the first group, first part of the index, and then I want row with value 0. And you can also concatenate horizontally. So we're going to concatenate one and just sort of spread it out to the right. And that's by specifying axis 1. And it's the same exact thing over and over again when we do that. So remember, axis 1 is working on the rows, axis 0 is working on the columns. So we can say also if we want our data sorted, so we can say, hey, sort A and D together, and yes or no. We can sort it out, and it sort of puts everything the way you would expect it. Um, just go back to the original, and um, so we can also do joins. So we can do outer joins, and we can also do inner joins. So let's take a look at that same data set, and instead of doing the outer join that we were doing, we're doing an inner join, and we can see that it drops everything that doesn't have that it drops everything that had the null values in it, and we only get back column B where we had the commonality between all of them. So that was data frame concatenation. We can also merge two data sets together. So let's take these two data frames. So we have a common column between both of them, which is name, but they have different information in that, and we want to get them. So we want to get all this information into a single data frame, so it's easier to work with. So we can go ahead and we can call PD merge and just merge our data set. And Pandas is smart enough to go and try to figure out that uh, where the commonality is between the two, and it tries to merge based on that information. So that's a simple example. Most data usually doesn't line up with that without some massaging. But let's take a look at another example where we're going to take, where the names might not line up one to one. So let's go ahead and merge on this, and we have James, who's a painter, and he doesn't exist in our original data frame. And we go ahead and we print it out, and we notice it dropped James. In order to get the information to stay, we're gonna do our outer join on there, and now James stays with his occupation, but we don't know his wage and age. But what if we have a many to one or a many to many relationship when our merge occurs? So let's go ahead and create a books, and we have three books here. So we have Good Omens, which is the title, and then and that was written by two authors, Terry Pratchett and Neil Gaiman. But then we have War and Peace, which is written by Tolstoy, and and then we have a collection of information here on the other side, and where we have the library of where the information's at. So we don't have we have all of our data matches on the common key of titles, but we have a lot of overlap. So let's see what happens when we combine this together. Notice that it was able to sort of handle that information for us, and we can see that we have multiple entries for each library and also for each author. So if somebody were to go, let's say this was part of a query and they were just looking up Terry Pratchett, they would see they have Good Omens, but the same, and they would see what both libraries existed, and the same with Neil Gaiman and everybody else. So it was able to handle it automatically, which was good. It makes our life a little easier. So let's go back to our weather data set that we've been working with for quite some time and load it in using the pandas.read CSV, and then we're going to rename some columns to make them a little easier to read. So we're going to rename M to month, D to day, participation amount just to participation, precipitation, snow depth to snow, air temperature to temperature, and just to give it more common names. And it's easier to work with this way. And then what we're going to do is we're going to group our data by a specific value. In this case, our common value is going to be month. And so there's 12 months in a year, and our data set consists of 365 days. So there should be 12 groups when we go ahead and we look at that. And we can see that we get 12. But notice that when we looked at our groups, we don't get that data frame that we've been expecting. We get back this group by object. So how can we go ahead and we can start and looking at it? So we can iterate through our groups and we can get information about it. So we can see how much information is in each group. You can see for each month, it's the number of observations for each one. Or we can get the actual information that's within each group. So I could say group.getGroup, pass in the index, and it gives us back that group's rows within there. We can also go and we could try to access column data, but notice we get back this series group by object. So it's not exactly what we were expecting. But if we want to get, we can get statistics off our groups by calling functions on there. So I have my groups, my series group by, and I can go ahead and call these common statistics. So I just do group column name, and then it'll calculate statistics based on the group sizes that we have. So when I call mean, we can see that we get the values broken up, and notice our index aligns with the month column that it aligns to. So we have our 12 entries and with the average values for each one. So that's pretty neat. We can also get the total. We can see how much it actually, um, how much precipitation we had for each month. We can see where the rainy months are, and we can derive other informational products out of that. So we can say our group for each month. Let's say you want to know the total amount of rain that occurred, and we want to show it on a graph. So we can just do precipitation for the groups dot sum, and then pass in plot, and then we just say kind equals bar, and we get back our bar chart that shows it off. But what we see here actually is something that's starting to creep up and affect um, our value, or some of our information, and that's because we still have those -1 values in there that we talked about in the previous slide, and we're going to take care of them now. So what we're going to do is we're just going to create a copy of our data, and we're going to use the lock with a query. So we're a precipitation equals -1 and snow equals -1. We're going to replace it with the value 0, and we're going to get back our new data set. Now we can go ahead and create our sums with our group by and see that we get different totals. So if we scroll up, then we would see that our numbers are larger than they were before. Now we could go ahead and let's plot this out, and we're going to see a slightly different um, result. This should do it. So now we don't have those negative values that we had before, and everything goes from 1 to 12 as expected, and we're not getting negative amounts of rainfall or precipitation. So aggregations aren't the only way we can work on data. We can also pass in filters, and filters are just simple functions that return Boolean values. So you can say, hey, data frame, I'm going to pass in a whole data frame, and you're going to say for this column, the sum is greater than 150, return true, else return false. And that's just another way of filtering out information. Uh, so we can do transformations that manipulate group data, but also retain the shape. And this requires another function. So here we're just going to pass in our transformation function. And while doing a concatenation, we get our data back, and it did this transformation. So we just did x minus the mean of that column. And then apply, what apply does, you can either have a function that works either on a group, a data frame, or a column itself. And these are functions that you pass in and are applied across the whole data set. So in this case, we're applying it to our month here, and we're going to sort the values and the temperatures for each group, and we get back this information. So we're saying, hey, group by month, apply this, and we're going to sort the values based on temperature for our data frame, and we get back our data frame. Time series is so if a measurement's made at a certain point in time, sometimes it's good to know how your data is lining up that way. So we're going to go ahead and create our data to create a new one. And we have our columns. So we have our year, month, day. So these all sort of, this information is important. And we can look at the information over a series of times. We saw how we could take information using those two functions before to convert it to numeric. But now let's see how we can use the pandas.toDate to work with this data as well. So I had mentioned earlier that you can convert timestamps, for example, milliseconds from feature layers into date time series. But what if your data is spread across multiple columns, which it often is when you get CSV data and other information? Well, the pandas.toDataFrame handles that, and we can we can basically smush together those three columns, in this case year, month, and day, and say, hey, this is a date time object, and I want to apply it to a new column called date. So we create a new datetime column and we say the information comes from these three columns in our data set. Let's take a look at it. Notice that date is created and we have this information. Now let's go ahead and drop out that information that we don't need anymore because we smushed it all together into a new column.date. We can then go ahead and we can set our index by date. And now we can, just like we were doing before with our integer columns, we can query and do slicing based on dates. So if I want the dates between the 15th of January and um, the 3rd of February, I can go and I can get that information back. So now we're doing slicing not on integers, but we're doing it actually on date times. I can go ahead and I can create ranges using the pd.date range, and then we can take the difference and then get that information back and get that information and view the dates that we were interested in. And if we want to find something that maybe applies to business days, we could go ahead and pull that information back as well, which is kind of interesting. So if you're only interested in when people are actually working, usually Monday to Friday, we could look at that sort of frequency pattern. Maybe you're looking at transportation and traffic and stuff like that. We can go ahead and we can plot the information, and notice that instead of doing the X column actually isn't the numerical values going from 0 to 365 now. It's going, or from 1 to 12, it's now going from this January 1st to December 31st, and we can see this information there. But it's kind of messy right now. We can't really tell how the data is trending. It's hard to read. So we can put in what's called, we can put some rolling information in there, and this will allow us and make the data the rolling mean, and this will allow us to see how our data is trending up and down over the average of that time span. Some additional information that's really important that I think you should look at is read this article on tiny data. If you don't want to read it now, later on in the course there will be a discussion that goes over this. There's also a Pandas cheat sheet that's very helpful. It's a PDF that has a lot of the functions on there. And as we use Pandas more and more throughout the class, towards the end, especially when we get to the spatial side of everything, you're going to see that you want to sort of take this information and you want to take this information and you want to expand upon it so you know how to use all these functions so you can really work with your data. The other thing that's pretty neat, if you work with a lot of multi-dimensional information, or you have high dimension data, so think like NetCDF data. Another library you could take a look at is Xarray. It's very familiar to Pandas, but it's different. We won't cover it in this class, but it's just something you should keep on your radar that maybe down the road you want to take a look at. So if you have any questions, please post in the forum, and have a great day.